AI models have too much bad data. Executive summary. Large language models have grown huge, but much of their data is low quality. More data no longer guarantees smarter AI. True progress now depends on better algorithms and cleaner, specialized data. High-quality sources in science, law, and finance can train smaller, more accurate models. The future of AI lies in smarter design, ethical data use, and thoughtful learning methods. Proving that quality, not quantity, drives real intelligence. Artificial intelligence has made huge progress in recent years. Many people believe this progress came from feeding machines more data. The biggest language models today are trained on trillions of words. They read much of the public internet, including books, articles, and social media posts. This sounds impressive, but size alone does not guarantee intelligence. As these models grow larger, they begin to face serious problems with the quality of their data. Too much data, too little quality. Large models learn from data that comes from many sources. Some of this data is helpful, but much of it is not. The web is full of information that is false, biased, or meaningless. When a model trains on low-quality text, it can learn bad habits. It may repeat misinformation. It may copy writing styles that are not clear or logical. It may form patterns that do not reflect truth or reasoning. Because of this, the model can sound confident while being wrong. More data does not always mean better results. Sometimes it means more noise and confusion. The challenge now is not how to collect more data, but how to choose the right data. Diminishing returns of scale. At first, giving a model more data improves its ability to predict words. But there is a point where adding more data does not help much. Researchers call this the diminishing returns problem. When a model already knows most of the common patterns of language, new data adds little new knowledge. The model grows heavier and slower, yet it does not become much smarter. Training larger models costs more money. It uses more energy and computing power. The benefit from this extra cost becomes smaller each time. This makes it clear that endless scaling is not the best way forward. The value of high-quality, domain-specific data. There are many sources of information that are far better than general web data. These include scientific papers, financial reports, legal cases, and technical manuals. This data is usually accurate and written by experts. Models trained on such data can perform very well in specialized areas. For example, a model trained on physics and math papers could help scientists design new experiments. A model trained on legal documents could help lawyers search for relevant cases. A model trained on financial data could make better forecasts and detect fraud. These special-purpose models do not need to be gigantic. They need to be trained with care and precision. In many cases, a smaller model with clean data will outperform a large model with messy data. The problem of access. High-quality data is often locked behind paywalls or privacy rules. Many journals, government records, or company databases are not freely available. This limits what AI researchers can use for training. Some organizations are working on ways to share data safely, but this process is slow. Without access to good data, developers are forced to rely on public sources, which are not always reliable. Data sharing must respect privacy and security. It must also reward those who create valuable information. Finding this balance is one of the hardest problems in AI ethics. Algorithmic progress matters more. In the last few years, models have started to show signs of reasoning. They can solve problems, plan steps, and even explain their logic. This improvement did not come from feeding them more text. It came from better algorithms. Algorithms are the rules that tell a model how to learn. Changing these rules can lead to major leaps in performance. Some key improvements include chain of thought reasoning, letting the model explain its steps before giving an answer. Reinforcement learning from feedback, teaching the model to prefer helpful and honest responses. Dynamic context management, helping the model remember important details during a conversation. Mixture of experts design, using different model sections for different types of tasks. These methods make models more efficient and thoughtful. They show that intelligence comes from structure, not just from size. Quality over quantity. The focus of AI research is shifting. Instead of asking, how can we get more data? Scientists are asking, how can we use data more wisely? A smaller data set of high-quality examples may teach a model more than a massive pile of random text. To make progress, developers must clean and filter the data they collect, remove duplicates, spam, and misinformation, label or organize data to highlight key patterns, combine data from diverse, trustworthy sources. When data is treated with care, models can learn faster and produce more reliable results. The role of human expertise. Experts in different fields can guide how data is used. Scientists, lawyers, teachers, and doctors understand their subjects deeply. Their knowledge helps AI teams design better training methods. Human judgment can identify which examples are most valuable and which are misleading. Expert review adds context that machines cannot see. Collaboration between humans and AI leads to better models. Human oversight also reduces the risk of harmful bias, ethics, and responsibility in data use. Using more data increases the risk of privacy violations. Some text on the internet contains personal or sensitive information. When models train on it, they may accidentally memorize and reveal it later. Developers must build systems that prevent this kind of leakage. Data must be anonymized before training. Sensitive materials should be excluded. Models must be tested to ensure they do not reveal private facts. Ethical data handling builds trust with users and society. A new frontier, smarter, not bigger. The future of AI will depend on smarter systems, not just bigger ones. Scaling up has reached its natural limits. Now progress depends on how creatively we design learning methods. Future advances may come from combining language models with tools like search engines or databases, giving models a way to reason step by step, using memory systems that help them learn across time, teaching them to evaluate their own confidence in an answer. These methods could lead to AI that is more thoughtful and self-aware. The role of small, specialized models. While large general models are powerful, smaller specialized ones have advantages. They are faster, cheaper, and easier to update. In many workplaces, a focused model is more useful than a universal one. For instance, a hospital might use a medical model trained only on verified health data. A law firm might rely on a legal model that understands local rules. A financial company might train a model that tracks market behavior. Each model can be tuned for safety and accuracy in its domain. This approach reduces risk and increases trust. The partnership between data and algorithms. Data and algorithms depend on each other. Without good data, even the best algorithm will fail. Without strong algorithms, even perfect data will be wasted. True progress happens when both improve together. To build better AI systems, developers must refine data pipelines. Researchers must invent smarter learning methods. Policymakers must set standards for fairness and safety. Working across these areas ensures that AI grows in a balanced and ethical way. Conclusion. The age of bigger is better is ending. Large language models have reached a scale where more data brings little gain. Many of the words they process are noisy, biased, or false. In contrast, smaller collections of clean, well-chosen data can produce much stronger models. The real key to improvement lies in better algorithms, cleaner datasets, and smarter design. Intelligence grows through understanding, not through volume. Algorithms shape that understanding more than raw data can. The next leap in AI I will come from quality, structure, and insight. AI will continue to evolve as humans learn to balance data with design. The goal is not to make machines that know everything. The goal is to make machines that think better about what they know.